9.7 is independent and dependent events. So you have probably heard your parents talking about, oh, or heard your parents say, oh, you're so independent, you can do your own laundry now, or oh, you're so dependent, I wish you would just learn how to make your own lunch for school. So you guys probably have a kind of a basic understanding of what independent and dependent means, and I can't write my definitions because of the way my pen's broken right now, but independent means two things that are completely separate events. So that's what I would write as just like my key would be separate events. They're maybe a spinner and a dice. The probability of finding something doesn't depend on the other. Dependent would be more like they're dependent on each other. So if you draw a green marble and you don't put it back, your probability of getting another green marble is reduced. And so that's dependent on the first event. So they two events that affect each other would be your dependent probability. 1A, one letter tile is selected and the spinner is spun. What is the probability that both will be a vowel? So the first thing I'm going to do is look at the tiles, and there's only, there are 2 vowels of the 4, so that's 1/2 of the tiles are vowels. And then I look at my spinner. I'm sorry, I wrote 1/4 and I meant 1/2. It's a Monday. And then I look at my spinner and I see how many vowels do I have, and I have 1 out of 3, so it's 1/3 of them are vowels. So I take 1/2 times 1/3, I multiply straight across, and I get 1/6. I circle it, and that's my answer. 1B, the 2 spinners below are spun. What is the probability that both spinners will show a number greater than 6? So the first thing we do is we have 10 sections total. And how many numbers are greater than 6? There are 3 of them that are greater than 6. Now, I ask myself, is this a dependent or independent event? And it is independent because I can spin this spinner and it doesn't change what I'm going to spin on this spinner. So even though they're the same, they don't affect each other. I multiply straight across, and 3 times 3 is 9. 10 times 10 is 100. So the probability of getting greater than 6 on both of them is 9/100. I circle it, and that's my answer. 2A, the spinner and number cube shown are used in a game. What is the probability of a player not spinning blue and then rolling a 3 or a 4? So the probability of not spinning a blue is 4 out of 5. And of rolling a 3 or a 4 is 2/6, which is 1/3. And then I multiply across and I get 4/15. So the probability is 4/15 of getting not a blue and then rolling a 3 or 4. Okay, 3A, now we are getting into dependent events. There are 4 oranges, 7 bananas, and 5 apples in a fruit basket. Ignacio selects a piece of fruit at random, and then Terrence selects a piece of fruit at random. Find the probability that 2 apples are chosen. So when Ignacio went to choose his piece of fruit, there were 16 pieces total. And there were 5 apples, so the probability of him getting an apple was 5/16. Once Ignacio chose, there were 15 pieces of fruit because he ate one of them. We're trying to find the probability that 2 apples are chosen. So if he had gotten an apple on the first try, that means there would be 4 apples left for Terrence to choose. So you're going to put 4/15. I'm going to cross reduce. 4 goes into 16 4 times. 5 goes into 15 3 times. Multiply straight across and you get 1/12. And you circle it, and that's your answer. This is the hardest thing for people to remember, is that picture it as Ignacio ate the apple. How many pieces of fruit are left? A lot of people will forget to subtract 1 there or not understand why. And so if you think about it, just think and you picture them eating the fruit or taking the marble out, that kind of helps to realize that there would be less marbles in the bag or fruit in the basket. Okay, so 3C is playing off of the one that we just read, but now it's saying what's the probability that Ignacio will get an orange and then Terrence will have an apple. So there were 16 pieces of fruit to start with, and there were 4 oranges. So the probability of Ignacio getting an orange is 4/16. And then we have 1 piece of fruit gone, so there are 15 pieces of fruit left. But there are still 5 apples because Ignacio didn't eat an apple. So the probability of Terrence getting an apple is 5/15. And I'm going to go ahead and reduce these before I multiply. So 4/16 becomes 1/4, and 5/15 becomes 1/3. And I multiply straight across to get 1/12. Then I circle it, and that's my answer.